Let me do this. So we are looking at rates and proportions today. That math 103.92. Don't worry about that. That's just a note for me. I'm about to switch the screen. But that's the title of the section today. Rates and proportions. All right, so let's go to 103. So I'd already had notes for rates and proportions for another class, so that's what that note was for. So it's not 9.2 for you guys, it's 2.1, but it's all the same content. So rates, a comparison of two quantities. It can be written as a fraction. So an example of that is 135 miles over 6 gallons, or 135 miles to 6 gallons. That divisional sign, that divisional bar, can also be read as per. So that's where you get miles per hour from. So that's miles over hours. So here we have 135 miles per 6 gallons. All right. A unit rate is a rate in which the denominator is equal to 1. So if I want to convert that 135 miles over 6 gallons to a unit rate, I would just divide 135 by 6. That would be 22.5. So that would be 22.5 miles over 1 gallon, which is 22.5 miles per gallon. All right. Questions before we go to the actual example? All right. So a dental hygienist, a dental hygienist earns $1,304 for working a 40-hour week. What is the hygienist's hourly rate of pay? So we know how much he or she makes for a 40-hour week. We want to know how much he or she makes for 1 hour of work. So we want to know cost per hour or dollars per hour. So that's how we would set it up. 1304 over that 40. So once again, that represents 1304 for every 40 hours. We want to know how much he or she makes for every 1 hour. So you divide 40 into 1304, which gives us 32.6. And that means that'll be $32.60 over 1 hour, or $32.60 per hour. All right, next one. Which is the more economical price or economical purchase? An 18-ounce jar of peanut butter priced at $2.69, or a 28-ounce jar of peanut butter priced at $3.99. So we want to know cost per ounce. So that'd be dollars over ounce. So our first relationship would be 269 over 18. Divide the 18 into the 269, and that'll be 0.149. So that's how much it costs per ounce. All right. Next one, $3.99. divided by 28, and that will be 0.143 per ounce. So that means the more economical purchase would be the 28 ounce jar for $3.99. All right. So ratios. This is a comparison of two quantities that have the same units. So the main difference between ratios and rates do not have to have the same units. So you saw what we had in that last example, dollars to ounce. Ratios have to have the same units. So it's going to be ounces to ounces or dollars to dollars. So that's what your ratios are. They can be written in three different ways. And you can write as a fraction, 2/3, colon, 2:3, or you can use the word 2, which is 2 to 3. Notice the consistency of whatever comes first will always be first, or it'd be your numerator, top number. And whatever comes second will always be behind the 2 or behind the colon or in the denominator. So make sure you keep that consistency when you want to set up your ratio. All right. Missing all my stuff. There we go. So a survey revealed that on average, eighth graders watch approximately, shortened up APP with approximately with APP, approximately 21 hours of TV each week. Find the ratio as a fraction in simplest form of the number of hours spent watching TV to the total number of hours in a week. All right. So they tell us to find the ratio as a fraction in simplest form. So we want to find a ratio, and what's going to help us set up the ratio is the keyword of 2. So whatever's in front of 2 is my first number or my top number, and whatever's after 2 establishes my bottom number, my fraction, or in other words, my second number. So the number of hours spent watching TV is my first number, and that is the 21. All right, they gave us that number. Then the second number, the description after 2 is the total number of hours in a week. So that we don't have, we'll have to calculate, and we'll do that in this way. We know there are 24 hours in a day, and we know there's 7 days in a week. So you do 24 times 7, and that is 168. All right. So the 168 is our bottom number. 21 is the top number, and then you reduce accordingly. And 21 can divide into 168 evenly, and that is by 8. So that'll leave you with 1/8 as your most simplified fraction. So if you didn't see the 21, the whole 21, you always can do it in pieces, recognizing that 21 is 3 times 7. So those are the only two numbers you have as options. So you can divide both numbers by 3, see if it cancels out, and do the same thing with the 7. And eventually you still should get to the 1/8. All right. Questions? Any questions? All right. So the unit ratio is very similar to your unit rate. It's a ratio in which the number in the denominator is 1. Unit rate was when you have a rate and the denominator is 1. ratio, unit ratios when your denominator is 1 in your ratio. So this next example starts off with a chart, a table. OSU is Oregon State University. So I just wrote a shorthand UO, University of Oregon, just in case you guys wanted to write it out. Don't know. So it gives us the number of men students for each, the number of women students for each, and then the number of faculty for each. So we have 10,018 men for OSU, 8,459 women, 1,471. And then for University of Oregon, 8,849,9824, then 1,364. From this table, they asked us to calculate the student to faculty ratio at OSU. Really just says student dash faculty, but that's what they're going for. The first number in your ratio is student. The second number will be your faculty. Round to the nearest whole number, then write using the word to. So first thing we need is the number of students. It didn't distinguish between men and women. You want all of them. So you add up the 10,018 and the 8,459, and you get 18,477. That's the total number of students at OSU. And once again, and also, I didn't say it didn't mean once again, but also it mentions OSU. So we're not looking at the information for the University of Oregon at this time. So we're only looking at OSU. So now we have the total number of students. We have the number of faculty. So you take, if you're trying to find the student to faculty ratio, you take the total number of students, place it over the number of faculty. And we want to know how many students per faculty member or per one faculty. So we go ahead and divide the 1471 into the 18,477. That gives us 1256. So that's 1256 to 1 or 1256 over 1. It tells us to round to the nearest whole number. So we take that 1256 to 13 and write the ratio with the word to. So it's a 13 to 1 ratio, student to faculty. All right, questions on that before we look at proportions? All right, so proportions is a statement that says that two ratios or rates are equal. So an example of that is 2 over 3 equal to 12 over 18. So the relationship that we will be able to use in reference to your proportions is your cross product. If you actually have a proportion, in other words, two fractions equal to each other, two rates or two ratios equal to each other, if you cross multiply them, then those numbers, those products should actually be equal to each other. So in other words, if I go A times D and B times C, in other words, take your denominators up to the opposite numerator, AD is supposed to be equal to BC. If that does not occur, then you do not actually have a proportion. All right, so go back to the 2 over 3 equal to 12 over 18. 18 times 2, take your 18 up, then take your 3 up to the 12. 2 times 18 is 36. 3 times 12 is also 36. All right. So if I have 8 over 5 equal to n over 6, and I want to solve for n, I would cross multiply. Or one way of doing it, let's say one way of doing it is to cross multiply. Take my 6 up to the 8, take my 5 up to the n. 8 times 6 is 48, 5 times n is n. Now divide by 5. And 5 cancels, leaving you with just N. Then on the left, you have 48 over 5. And my math lab will let you know what they want from you. You can either leave it at 48 over 5, or if you need a decimal, divide it out. You have 9.6. Any questions? All right, so if you travel 290 miles in your car on 15 gallons of gas, how far can you travel on 12 gallons of gas under similar driving conditions? So first thing you want to do is set up a proportion. Whatever you do, make sure you stay consistent in your setup. If you decide to do miles over gallon, like I decided to do, make sure you're consistent with your other rate. So if you do miles over gallon on the left side, make sure you do miles over gallon on the right side. You can actually do gallons over mile, doesn't matter. Eventually you'll come up with the same answer. You can even play with it a few other ways, but just make sure whatever you do, stay consistent. So I'm going to do miles over gallon. And my first relationship is 290 miles over 15 gallons. I'll set that equal to, it says how far can you travel? So that means my unknown is X, my mileage is X, and I place that X over 12 because I want to know how far I can travel on 12 gallons of gas. So cross multiply, take your 12 up to the 290, take your 15 up to the X. 290 times 12 is 3480. 15x is on the right side. Divide both sides by the 15. Variable, the number in front of the variable cancel. And 3480 divided by 15 is 232. So you can travel 232 miles on 12 gallons of gas. Well, this down here was nothing in particular that you have to do. Someone was asking me about a breakdown in last class, so I don't worry about that. Just if you follow the process, you will get to 232. All right. So next one. The dosage for a certain medication is 2 ounces for every 50 pounds of body weight. How many ounces of this medication are required for a person who weighs 175 pounds? So once again, you want to stay consistent in your setup. Establish how you're going to set up your ratios or proportion, your rates and your proportion, and stay consistent. I decided I was going to do ounces over pounds. So my first relationship is 2 pounds, or 2 ounces, excuse me, over 50 pounds. Then it says how many ounces, so that's my X. How many ounces of medication required for a person who's 175 pounds? That's on my denominator because we're doing ounces over pounds. So 2 over 50 equal to X over 175. So you cross multiply 175 times 2, 50 times X. So that 175 times 2 is 350. 50 times X is 50X. Divide by 50 in order to get the 50 off of X. 350 divided by 50 is 7. So X is equal to 7. And that means 175-pound person requires 7 ounces of this medication. questions? Any questions? Any questions? So that's the foundation of what you will be doing. Somebody last class, where's that stuff? This was a specific question that somebody was asking about something else, so that has nothing to do with you guys. Somebody asking about some problems on the actual homework. So one of the first, I think it was like the first one, asked about A to B. They give you A and they give you B, and then tell you to write the ratio of A to B as a fraction and simplify it. So all you would do is for A to B, that would be 210 over 520. The zeros can cancel in the back because they represent multiples of 10. And so the answer is 21 over 52. Then it asks you about B to A. So that all you do is write the B on top, A on bottom. So really all they're doing is making sure you understand the relationship of two and how you're setting up your ratio. Then that in that same question it says A is blank percent of B. So if you want to find how much of a percent A is to B, you would take A over B, divide it out. So 21 over 52 gives you 0.4038. And they tell you to round your percentage to one decimal place. So don't forget, whenever you're looking at your decimal representation of your number, if you want to convert it to a decimal, to a percent, you move your decimal 2 places to the right. So that's what we did right here. And that'll give you 40.4%. So a lot of them were variations of the two relationship, number in front, number in back of the two, number behind the two, and making sure you understood how you set it up as a fraction and reducing. And so then they had another one like this. So they said 3 to 3 and 3/5. So that's 3 and 3/5. So I set it up as a fraction first. 3. 3 is my top number. And then 3 and 3/5, my bottom number. And that 2 is represented by that divisional sign. So in order to simplify further, you're going to have to convert that 3 and 3/5 to an improper fraction. So that's the whole number times your denominator plus your numerator. So that's why I have 3 times 5 plus 3. And that's divided by 5. You always keep that same denominator. And so that's 3 times 5, which is 15, plus 3 is 18. So it's 18 divided by 5. Or 18 over 5 is your fraction. So now replace that with 3 and 3/5. So that's 3 over 18 over 5. So then to simplify it further, it's written vertically. I decided to go ahead and write it horizontally. That divisional bar is the same thing as that divisional sign. And so then when you go about dividing fractions, don't forget that means you multiply by the reciprocal. So your division sign changes to multiplication. You flip the fraction that immediately follows. So that 18 over 5 turns to 5 over 8. Then to reduce further, or to reduce before I multiply, I look at the 18 and see that 18 is 3 times 6. So I cancel out my 3, and that leaves me with 1 times 5 in the numerator, which is 5, and 1 times 6 in your denominator, which is 6. So that's 5 over 6. So, like I told the last class, notice this wasn't an intro to fractions. And they didn't spend time, going over fractions. So if you forgot your fraction work, you haven't spent time doing it, of course, most people are not spending time doing fractions on the beach. So if you lost some of your fractional skills or whatever, make sure you get with me, make sure you get with a tutor and get with somebody so you can make sure that you're okay with adding, subtracting, multiplying fractions. Because you see, it leans on that. It leans on you simplifying your fractions. I got videos that I've made for other classes, so I still have, on the same YouTube channel or whatever. So I have stuff I can send you. And then if you just need to talk, I already talked about how you can set up a Zoom session with me. But whether it be setting up a Zoom session, looking at old videos, or setting up a Zoom session with the tutoring center, make sure you secure your foundation. Because once again, this class isn't about adding, subtracting, multiplying, dividing fractions, but they do expect you to be able to do it in order to be able to complete the assignments that they ask of you. Any questions? Questions on anything?
I got a question. So we're supposed to be all caught up and be at 2.1, right, for the homework wise?
That would be your best case scenario, yes. But I do know that a lot of people, aren't necessarily there. So that's why I'm not, we got plenty of time right now, but I'm not going to go into a new section because I'm trying to get everybody in the same place or as close to the same place as possible. So that's why we're just going to stay here. Next class, we may get into 2.2. We'll see, but that is best case scenario that you've done all of your 1.1, 1.2, 1.3. I think there's a quiz at the end of chapter 1. And then you just covered 2.1 today. So, and then of course your Excel assignment. So that is best case scenario. Questions, concerns, comments? Notice I haven't put a due date on anything yet. Once again, like I just explained, trying to get everybody close to the same spot before you even dare talk about a due date. So, yeah, take advantage of that, as far as the no pressure. Questions, concerns, comments before we close? Anybody? Okay. All right, that's good to go. If you guys are good, I'm good. Once again, not saying we're always going to let out early, but I do want to make sure that we secure this Excel stuff. So make sure you guys, if you're having issues with Excel, make sure you get with me or get with somebody so you can start submitting these assignments. And once again, just reiterating or reemphasizing the fact that if you can't do the Excel, that's fine for right now, but you still can do the homeworks that don't have anything to do with Excel. Because there's a 2.1 assignment, homework assignment that has nothing to do with Excel. And that's what we just talked about today. All right. So if you're good, I'm good. I will see you guys next week. Have a great weekend. Be safe. And I appreciate you guys coming out. All right. Yes, if you had a question about it, feel free to stay back. Other than that, I will see you guys on next class.